name is Deepak, and I'm completing this project as part of the training module. So in this project we build a model to predict the electrical output energy of a combined cycle power plant. And from the data set that I have downloaded, I have 99,568 rows of data, and that is split into five features: temperature, ambient pressure, relative humidity, exhaust vacuum, and PE. So the prediction value what we have to predict is the PE based on the other four features. So out of the three modeling options which we have, I chose Google Auto ML using Vertex AI, and this is going to be a supervised machine learning approach, and we are going to go through regression for our target variable, which is PE. And this data will be automatically split once I input into Vertex AI. It will automatically split into 80%, 10%, 80, 10, 10, which is 80 training data, testing and validation data. And so the input features, we are giving two different models. The one is for all four other than PE, and the second model we are just considering only two features, and PE will be the output here. And there are different types of algorithms which are run automatically by AutoML in Vertex AI. We have linear regression, random forest regression, boosting regressor. So out of all the regression will be run, and the best performing one will be automatically selected here. And also for validating, uh, the AutoML is going to use five-fold cross validation. So it will split the training data into five parts and evaluate it in a much more robust way. So the results after running this uh, uh, model, right? So what I got is that for model 1, where we have PE as output and rest of the four as inputs, the 80 atmospheric temperature has higher contribution, which is 63.3 percentage, and the second most influential will be 23.4, that is V, and AP and relative humidity are very less percentage. So you can see them in the graph. And for model 2, other than PE, we're considering AT and V, and whereas AT is 69.3 percentage and 30.7 percentage for exhaust vacuum. And comparing this both, right? So I've got the results from MAE, MAPE, and RMSE and R square. Out of these, uh, the highest value for R square is 0.954, which is 95.4 percentage, and so the 95.4 is an excellent predicting capability, and the errors are very low, and the deviation is 6.089%, which indicates very minor relative deviations in predictions. So walking through the UI, I've created different data sets, and if I go into one of them, you can see the number of rows and columns are created here. And when I go into training, I create one training data set for the first model, and for this model you can see the details here, the feature importance. When I hover over, I can see the different details. When I click on deploy and test, you can see that I can give different values and test out. When I click on predict, it will show me the prediction results 408 and with 95% prediction interval. So this is how I've completed uh, the project. So same way I've done it for other two models, and upon comparing these both values, the best option for us to go with will be model 1, where we have 95.4% prediction accuracy.